Matt, what's with the balloon? What are you doing?
I'm creating wind!
Oh. Wow. Why?
Well, somebody was whining about all the snow here in Fort Collins. And why doesn't the snow just stay up here in the mountains like it's supposed to? Keep the snow up there where it belongs, blah, blah, blah.
Well, this year does seem to be a bit different. Why have we had so much snow here in town this winter anyways?
Good question, and I have a great answer. It's called upslope. I'll explain it, but first let's say hello to everyone.
Right.
I'm Matt.
And I'm Scott.
And we're from
Pooter High School. Today, we're here to share some weather and water information for the month of December 2009.
We're tracking our water accumulation for the 2010 water year through its natural cycle, from October through the following September. We report on precipitation, rain and snow or anything that falls from the sky.
Also stream flow on the Pooter River.
And water storage in Horsetooth Reservoir.
Okay, so what about upslope and all the snow here in town so far this winter?
For a perfect upslope storm, you basically need 3 things, like a 3-step recipe. It all starts with wind. Do you ever wonder why the wind blows?
Well, I don't know. I've never really thought about it. It's moving air. It's the big fat guy sitting up in the sky going whoosh.
I can see we have some work to do.
Oh.
When I let go of this balloon, what happens to the air from the inside of the balloon?
Is this a trick question? 'Cause it comes out.
Yeah, and we've all seen balloons deflate, and we know it's because the air comes out. But why does it come out?
I'm not sure. Because there's nothing to hold it in? Or the difference in air pressure?
Now we're getting somewhere.
Oh.
Which has the higher pressure? The air that was inside the balloon or outside the balloon?
Inside.
Right, because air always moves from a higher pressure to a lower pressure. What happens when you press on the valve stem of your sister's bicycle tire?
Well, first she gets really angry, then she starts...
Okay.
Oh, well, the tire goes flat because it's higher pressure inside the tire than outside the tire.
Sure, there are all sorts of examples. Spray anything like silly string or hairspray. You know, contents under pressure?
High pressure to low pressure again. So the moral of the story is that air will go in any direction, north, south, east, or west, to get to a region of low pressure. This must be the first ingredient of our upslope recipe.
And when we talk about it on the scale of weather, air can even go uphill over a mountain range to get to an area of lower pressure. That's key to in our area.
In weather, what's the difference between high and low pressure?
A low pressure area sucks air in towards the center. A high pressure area blows air out from the center. The result is air moving from place to place. Wind. All across the world, there are high and low pressure systems of air moving around. Weather moves from the west to the east.
Okay, I get it. So we usually get more snowstorms from the west side of the mountains, where the snow should be. What happened this month?
Well, that brings us to our second ingredient for upslope. Sometimes a low pressure area forms here, causing our winds to come from the east instead, and in our area to the west. What is the major obstacle they have to get over?
I would have to say the mountains.
Right, and something very interesting happens when air flows up and over a mountain range. Clouds form. It's like moisture in the atmosphere. The moisture is there, but you can't see it. It's like this sponge. I'll fill it about half full. The sponge holds all this water without dripping, which is like a cloud that isn't raining. But what if I fill the sponge completely full?
Oh. A lot of water.
It will probably start dripping. And that's what happens in the air. The cloud is always filled with some amount of moisture, and it would rain or snow if enough moisture was added. It would reach its saturation point and would start to drip out. But I could also make the water in this sponge drip out without adding any more water. Got any ideas?
you could squeeze the sponge. You can make the spaces smaller when you squeeze it, so it won't hold as much.
Exactly. And that's just how it works in the air. But the question is, how do you squeeze the air? You make the air colder. At lower temperatures, clouds can't hold as much moisture, so they start dripping or raining. Now, what happens to the temperature of the air when it has to rise way up as it travels over the mountains?
It gets colder.
Exactly. When that air has to rise from the lower elevations of the eastern plains to the elevation of Fort Collins, let alone over the mountains, the moisture inside of it gets squeezed out, and it can bring precipitation.
So what's the third ingredient for our upslope snowstorm?
That's the easy part. In the middle of winter, the precipitation that is squeezed out doesn't fall in the form of rain, it falls as snow. These ingredients combine to form what we call an upslope storm.
So an upslope storm brings more rain or snow to the eastern side of the mountains, along the Front Range where we are.
And when the winds are from the west, we get more snow on the western side of the mountains than we do here on the east side. And that's what usually happens.
But this December, we had several upslope storms.
And cold enough that snow doesn't go away.
Got it. Let's see how this snow has changed things with our snow accumulation here compared to the high country. And we start with the snow that fell in Fort Collins for the month of December.
How does our snow this month compare to long-term averages?
Well, we typically get 8.4 inches of snow in December.
This December, we had 20.3 inches of snow. It was our fourth snowiest December since 1883 and almost 12 inches above normal.
Jeez. And how does all that snow result in our total precipitation numbers, meaning rain and the water content of snow?
On average, we get about half an inch of precipitation in December. This year, we received 1.1 inches, which is over half an inch above normal.
That's one of the reasons we've had way more snow in Fort Collins than usual. So let's compare that to mountain snow. For that, we go up to Joe Wright Reservoir in the Poudre Canyon, almost to the top of Cameron Pass.
The smooth blue line shows the snow water equivalent, meaning the water content of snow over the past 30 years.
That's right, Matt. And this red line is the amount of snow water equivalent that has fallen at Joe Wright so far.
Do you notice that we haven't gained much snow in the high country during the month of December?
Well, it hasn't melted. Some of the snow is apparently blown away. Oh, and we've had more upslope storms.
Let's hope the Pacific or Western storms start a-coming. We need mountain snowpack. It stores all that water we use throughout the year.
This brings us to a connection between precipitation and stream flow.
Right, but not much to report on this month since the river is mostly frozen.
Here's our hydrograph of the Poudre River. Our average flow in blue and our current flow on the Poudre in red. We're at low flows called base flow until all that snow starts melting during the spring runoff.
Let's look at the water storage elevations of Horsetooth.
Last month, we were at our lowest water levels in Horsetooth so far this year.
What about this month?
The water managers have started to fill it now. We've gained 3 feet of water level elevation since last month.
I'm glad to know that the water is rising again in Horsetooth.
And I'm glad to know that I know the 3 ingredients for the perfect storm in Fort Collins.
Right. Number 1, a low pressure that forces the winds to come from the east. Number 2, the rise over the mountains which cools the air and forms clouds and precipitation. And number 3, temperatures below freezing that produce snow instead of rain.
Good report, Matt. Hey, we'll see everyone in a month for a recap of water conditions for the month of January 2010.
See ya.